Rise and shine, porcupines. You know what time it is. It's Algebra with Al time. And I'm your host, Al Rosetti. Now today, students will be able to identify the domain and range of a function. The concept is domain and range, and the skill is identification of a function, not a function. So what do you say we get going? All right, so here we have a set of ordered pairs given in the table. Now first let's identify the domain and range, right? Now the domain is all the x values. The range is all the y values. We use these fancy words when we're talking about basically functions. Otherwise we would just say x and y. But we're talking about functions, we're talking about graphing, so we're going to use the word domain for all the x values and range for all the y values. So the first one, they give it to you. They set it up where the domain is given to you and the range is given to you. But normally you would see x on the left side and the y on the right side. So if the domain is all the x values, well then 100, 200, 300, that's your domain. And the range would be 50, 100, and 130, or 150, my bad. So, is it a function? Yes, it's a function because each one of the x values is paired with a different and unique y value. Okay? So, yes, it is a function. All right? What type of function? Well, it is both. It is onto and it is one-to-one. Okay, number two. Once again, they identify the domain and the range at the top of that map chart. And so the domain is 3. The range, well, once again, they identify it, which is 1 and 5. Now, is it a function? It is not a function because the x value 3 has 2 different y values. That's like a husband having 2 wives. That's not acceptable. Okay? So, if it can, one husband, one wife. Okay, let's look at number 3. So here now is how you're going to be presented these for the most part. You're going to see an x and y, and you're going to know that domain is all the x values. So domain in this case would be 1, 2, and 3, and the y is all the range, right? The range is all the y values. So 2, 4, 6. Now, is it a function? Well, 1 to 2, right? 2 to 4, 3 to 6. Each x has its own y. So yes, this is a function. Number 4. Okay, now this is presented to you on a graph. It's a little different, but think about it. The domain is all the x values. So given that circle that they drew, x is going to be what? Greater than or equal to 0, but less than or equal to 10. Okay, the range, once again, it's going to be greater than or equal to -2, but less than or equal to 8. So this is how we would identify the range. Now, is it a function? No, it is not a function because each one of the x's does not have a unique y. Okay? All right, so let's look at the next ones. Number 5. Okay, once again, it wants us to graph these functions. Okay, it wants us to graph these ordered pairs and then determine function, not a function, what type of function. And then this is a new thing. They want to know if it's discrete or continuous. All right, so let's go ahead and do this. So the domain is just 2. The range is -3, 4, and -1. Is it a function? No, it is not a function. Why? Because 2 has 3 y's here, right? -3, 4, -1. It's got 3 different y values. It can only have one unique one. So, not a function. Is it discrete or continuous? It is discrete because it stops. It does not draw a line, a continuous line. It is discrete. All right, let's move on to number 6. Here, nothing really special here. You can see that the domain is 2 and 6, and the range is going to be 6 and 2. So we plot the points. You can see that it does not draw any kind of line. You know the answer is going to be discrete Is it a function? Yes. What type of function? It is both. Okay? Onto and one-to-one. And the key here, let me go over the discrete and continuous. If your points draw some kind of a line that extend infinitely, that's when we're talking about continuous. All right. So number 7. All right, let's plot the points. Now, what's the domain? -3, -2, -1, and 3. Those are all the x values. That's what domain means. Okay, let's go back to the graph. The range, 4, 4, -1, and -1. Now when we list the range, we only have to do those numbers one time, even though they show twice, 2 4s and 2 -1s, we're only gonna list it one time, okay? All right, is it a function? Yes, it is a function because each one of the x's has a different y. Even though 4 is used twice, it's a different x value it's assigned to. So yes, this is a function. Okay, is it discrete or continuous? It is all obviously discrete. You're not drawing any kind of line here. There's nothing to show. It continues on. All right, last one, number 8. X is equal to -2. Well, pretty straightforward. Since the domain is all the x values and there's only one x value given, that's -2. They're stating that no matter what the y value is, x is -2, no matter what you put for the y. So the range in this case would be all real numbers because any y I choose, x will be -2. All right, is it a function? Well, obviously it is not a function because -2 will have any y value you give it. Okay. All right, so now what we're going to do is we're going to evaluate functions. We're evaluating the functions. They're giving us f of 0. So the f means we're going to plug it into the f of x. We're going to simplify and come up what does that equal when we put f of 0 in it? So math is simple. Once you understand how to apply this, the math is elementary, like 2nd, 3rd grade stuff. So all we're going to do is substitute 0 in. We get 2 times 0 is 0 minus 1. Well, that's -1. So we want to write it f of 0 equals -1. So we know what value you substituted in. All right, 10. We got f of 12. Same thing. 2, open parentheses, 12 minus 1. 24 minus 1. So when I substitute f of 12 in, I get 23. And that's how we want to show the answer. We have to know what you substituted in and evaluate it to get your answer. All right. Number 11, now we got g of 4, so now we're going to use the g of x instead of the f of x to simplify this. All right, so g of x, well, we have 2 minus x squared, so we're going to put 2 minus 4 squared. 4 squared is 16, 2 minus 16, well, I hope we all know that's -14, right? Okay, so g of 4 equals -14. That's how we have to write our solution. We have to know what to evaluate. All right, let's look at number 12. Now we're back to the f of x. They're telling us that f of x, in this case, we're going to substitute in -2. So we're going to write it out. F of -2 equals 2 parentheses -2 minus 1. So 2 times -2, -4 minus 1. You should have gotten -5. So really this comes down to being able to multiply, add, subtract, divide positive and negative integers. If you're solid with that, this should not be an issue. All right, so f of -2 is -5. Let's look at 13. G of -1. So now we're back to the g of x. We're going to write that out, g of -1, so we know what we're evaluating with. Then 2 minus, and in parentheses, put -1 squared. Okay, so it's minus another -1 squared. So -1 squared is a +1. Then we have 2 minus a +1. Do not mess up on these signs, okay? make sure you put the parentheses, don't skip any steps, because inevitably, even if you get the correct answer, you'll probably drop the sign. And g of negative 1 in the end equals 1. All right, 14, f of d. Now you say f of d, where's the number? Well, we're not going to use a number. We're simply going to substitute d in for the variable and see where we end up. You're not going to get a number like you would on the other ones. You're going to get some type of an equation. So we substitute d in, we get 2 times d minus 1, and we have to stop right there. That's all there is to it, 2d minus 1. That's the answer. Okay.